Hello, we're going to start going through the Chapter 3 test review together. A lot of these you're going to be able to solve different methods, but I'm going to work out a method and try to mix up the methods so you can have a variety of different types of problems to look at. So for the first one it says, is it independent, dependent, or inconsistent? And try to do it without graphing. So independent means that if we were to graph it, it would have one solution. And dependent means it's going to be the same line. And inconsistent means that it's going to be parallel lines. So to tell this without graphing, we need to find the slopes. So we're going to put it in slope-intercept form. So for the first equation, we just need to get rid of that negative. So we're going to divide everything by -1. So we'd have y equals -x plus r5. And then our second equation, we need to get this y by itself, so add the 10 over. And then we have 2y equals -2x plus 10. To divide everything by 2. And we get y equals -x plus r5. Now notice once we get the y's by themselves, for both of these they're the exact same line, same slopes, same y-intercepts, so since they're the same line it's going to be dependent. Well, this next one we're going to do the same concept to get the y by itself, so we add the 7, so we have y equals 2x plus 7. The second one, we need to get this y by itself, so we can just add the 2y over. So we have 2y equals 4x plus 4. And then from here, we need to divide by 2. And we have y equals 2x plus 2. Now for this one, notice how they have the same slope, but they have different y-intercepts. So those are going to be parallel lines. So we're going to put that it is inconsistent. I know on the review there isn't one for the independent one, but how you're going to tell that it's automatically independent is the slopes are different. Then we know that they're going to cross somewhere. Alrighty, the next section, we can do these by substitution, elimination, or graphing. So for this first problem, since the y's are by itself, I'm most likely going to choose to graph. So I'm going to get the graphing calculator out. The y's are already by itself. So if we go to just y equals, we're going to type those in. So 2x plus or 8. Graph the next one, 3x minus 1. So we have our two equations in there. We're going to click graph. And notice how it crosses higher. So we need to either zoom out, click zoom, and then go zoom out. And if that doesn't work, then we'll keep working with our windows and changing our x values, so they, or our y values, sorry, until they're higher. So second trace, go to intersect, or down to 5, click enter. And then 926 is going to be our intersection. Since we are zoomed in, if we just want to go back to the standard window, then we would just go click zoom and then standard. We get back to that basic screen for the next problems if you kept graphing it. Alrighty, the next problem, we're going to do a new method. So instead of graphing, let's do this one by the substitution method. So substitution, we need to get a variable by itself. So let's get this y by itself since there's no number in front of it. So we're going to have 2x minus y equals 2. So subtract the 2x. We get -y equals -2x plus 2. And then divide by -1. So we get y equals positive 2x minus 2. And then we're going to substitute this in for our y in our second equation. So we have 2x minus 2 times our 2x minus 2 equals our 4. And then notice we just have x's, so that is good. We're going to solve for our x. So we have 2x minus 4x plus 4 equals 4. So 2 minus our 4, we get negative 2x plus 4 equals 4. Subtract our 4, we get negative 2x equals 0, so x is going to equal 0. And then from here, we're going to plug into this other equation that our x equals 0, and we're going to solve for our y. So we get 0 minus our 2, so just y equals negative 2. And then this next problem, we're going to use the elimination method. So notice if we try to add right from the start, nothing cancels out. These are the same side, so one way we can do this is just multiply one of these equations by negative 1. Another method we could use is multiply this top equation by 2, so we have a negative 2x and a positive 2x. So maybe multiply this one by negative 1. So it's just going to switch all the signs to the opposite. So 1x plus 2x, we get 3x equals negative 3. So x is going to equal negative 1. And then we're going to plug it back into either equation and solve for our y. So I'm going to use this second equation. So then we're just going to add this 2 over. So y equals positive 1. And make sure for those problems you're going to get to pick and choose which method you use. So if you like the graphing, the substitution, or the elimination, you can choose either method. Now this next part, it wants to solve the system of inequalities. So we're going to have to do this by graphing because we need to take a look at the dotted versus solid line and then the shading. So for this one, the y is already by itself. I did not bring graph paper with me, so we're going to do it without graphing, or without graph paper, so I'm just going to make a sketch. Our y-intercept is negative 5. Our slope is 1, so we're going to go up 1 over 1. Up 1 over 1. Okay, notice there's no bar underneath of the inequality, so it's going to be a dotted line. And then it is greater than that, so we should add everything higher than that. Then we go to the next one. The y is not by itself, so we can either do the cover-up method or we can get the y by itself. So if we get the y by itself, it's going to be negative, or y is less than or equal to negative 3x minus 2. So our y-intercept is negative 2, and then our slope is negative 3. So down 3 to the right 1. Or we can go up 1, 2, 3, and then over 1. And then it's going to be, there's a bar underneath of it, so a solid line. And then it is less than this, so notice the numbers get less than below it. So we're going to shade everything below it. So this side. So notice over here in this part of our graph, that is where the overlap is. So that would be the part that we shade. This next one, the first one's going to be a line. And then notice the second one, it has absolute value bar, so it's going to be a V shape. And actually for this one, let's use the graphing calculator, just in case we forgot how to put the absolute value bars in our graphing calculator. It will be a good review. So for the first one, we're going to type in x plus 2. Notice how it is less than, so we're going to arrow over to the left until it's blinking, and then we're going to shade less than. So it should be blinking below. Then we're going to type in the next one. To get those absolute value bars, we just need to click on Math, go over to Number, have the ABS highlighted, click Enter, and then do x minus 3, parentheses, and then plus 1. and then it is greater than this, so we want it to be highlighted above. Oh, I passed it. So it's highlighted above. And then if we click graph, it's going to graph that first line, and then it's going to graph our V shape. Now if you do this on the graph, then I do need to see your graph, so just make, for example, what you see on the screen. So it's an increasing line, and then a V kind of going like this. And then notice the overlap is this part right here. So that would be my graph. Alrighty, the next one, we're going to set up the equations. It says you have 10 fewer quarters than dimes. So for that one, let's start labeling everything. So maybe our quarters is going to be our Q, our dimes is going to be our D, and our nickels will be our N. You can use X, Y, and Z also if you would like to. So we have 10 fewer quarters than dimes. So notice how we have less quarters than dimes. So we want to either add 10 to our number of quarters to get our number of dimes, or we can subtract 10 from our dimes to get the number of quarters. But make sure we have fewer quarters. So we're going to add to get to the number of dimes, or we're going to subtract the number of dimes to get the number of quarters. Now our second equation, we have 5 fewer nickels than quarters. So we have less nickels, so we need to add 5 to it, so it equals the number of quarters. And then the total value of coins we have is $4.75. So for this, notice how we have nickels, dimes, and quarters. So we're going to have a money equation. So it's 10 cents times our D plus 5 cents times our N plus 25 cents times our Q equals our total amount that we have for money, so $4.75. So we have our three equations. We could use either substitution, elimination, or the matrices to solve for this one. I'm going to probably choose to do this one by the matrices. So we haven't done one using that method. So for this one, we got to get our like terms lined up. So since this one has the D for dimes, nickels, quarters, and then our answer column, and then I'm going to set up the first two equations in that format. So I need to move the D over to the left-hand side, so minus D, minus D. We're going to have negative D, and then my Q I'm going to bring over here so it's underneath the like term, and then equals, and then this 10 I'm going to move it over to the right hand side, so subtract that 10 over. And notice I have nothing in this spot, so I'm going to have to put a 0 as just a placeholder there. And then my next equation, I have 1n, so I'm going to put that in the n spot. The q I'm going to have to move over, so minus q. And then the 5 I'm going to have to move over to the other side, so minus 5. And I don't have anything in the D spot, so I'm going to have to put a 0 as a placeholder. So then this is going to be the numbers that I'm going to plug into my matrix. So I'm going to grab my calculator. I'm going to go to second matrix, go over to the last column, edit, click enter. It's a 3 by 4 matrix, so click 3, enter, 4, enter. And then I'm going to type in all of these values. So 0.10, 0.05, 0.25. Good night, Kendra. Good night. 0.75, negative 1, and then I need my 0, 1, and negative 10. And then my last row, I'm going to have 0, 1, negative 1, and negative 5. So once I get these all typed in, I go to graph clear, just get out of the screen, and then second matrix again. Now I'm going to go to the middle column and go down to RREF. And then click enter, and then second matrix one more time. And then I typed in a matrix A, so I'm going to have matrix A highlighted. Click enter, and then click enter one more time. So this tells us we do have a solution, the one's diagonal, so we want to check that first. And then the x value is 20, or we used, sorry, dimes, nickels, and quarters instead of x, y, z. So our first variable was our d. So for dimes, we have a total of 20 of them. Then we used n, so our nickels is going to be 5 nickels, and our quarters is going to be 10. Okay, and you could check your work and make sure then these equations work with that. Alrighty, the next one is we need to graph our constraints and then find our vertices and then plug in our vertices to find our maximum or minimum value. So for this one, I'm going to sketch a graph. And again, graph paper is going to be a lot easier for you to use, so try to grab some graph paper. So for this first one, it's x is less than or equal to 3. So we go over to 3. We make that vertical line. It's less than that, so we're going to shade everything to the left of it. Then we go to the next one. It's y is less than or equal to 7. So we go up to 7. And we make that horizontal line. And notice how it is less than that, so we shade everything less than that. So this part over here is the overlap so far. And then we have x is greater than or equal to 0, so we go through 0. And it's greater than that, so to the right of it we shade. So this middle part is all shaded now. And then y is greater than or equal to 0, so that's going to be this axis. And then it's greater than that, so we shade everything above it. So right now this rectangle is all the overlap. And so then we're going to have to label these vertices. And we're going to then plug them into this objective function. So we have 0, 0, 0, and then 7. And then we're going over 3 and 0, and then over 3 up to 7. So then we're going to plug all of these into this objective function. So the first one we get 0. And then we get 0 plus 21 is 21. We get 6 plus 0 is 6. And we get 6 plus 21 is then 27. And then we need to label our minimum and maximum value. So 0, 0 is going to give us our minimum value. And then 3, 7 is going to give us our maximum value. Okay. The next one, I'm just going to show you what the graph is going to look like. So when you graph it, you can take a look at your coordinates and make sure that you have the correct one. So your graph should look similar to this. You should have a vertical line here, horizontal line here, and then 2 decreasing lines. So your vertices are going to be 0, 0, 0, 20, 10, 10, and 15, 0. And then you'll see that your maximum is going to be this 0, 20, and then your minimum is going to be 0, 0. And then your last one, again, you see our graph, you can see our x-axis is right here, our y-axis is right here. These over here is all of our vertices, and then our minimum is 1, 2, and our maximum is going to be 6, 4. Alrighty, if we go to our back side of our review, whoops, let me go back and we'll keep working through them. So for this first one, they gave you the matrix. We just have to type it into our graphing calculator. So we're going to go to second matrix, over to edit, click enter. It's a 3 by 4. We're going to type in these numbers. And then once we have them typed in, go to graph clear. Second matrix, go over to math, go down to RREF, click enter, second matrix, Click enter again. The ones diagonal means there is a solution, and then the solution is this column on the right. So 6, negative 3, 1. Okay. On the test, it is going to have a couple problems that, let's say this is matrix A, that if it says matrix A, what is in the first row, third column? Then we will have to tell what number is in that spot. So the first row, third column, rows go left to right, columns are up and down. So if we want to know first row, we're looking at this, and then third column, and notice negative 3 would be in that spot. So you would just put a negative 3. So let's try another one. If we want matrix A, what is in the second row, maybe fourth column? Then let's try this one. So second row would be this one. Fourth column would be this last one. So then 5 would end up being in that spot. So we're going to put down a 5. So just remember the first number always tells your rows. So that's left and right. This is first row, second row, third row. And then the second number is columns. So that's up and down. So first column, second column, third column, and then fourth column. Alrighty, these next ones, it says solve each system of equations. You can use substitution and elimination, a combination. So combine two variables, eliminate, or combine two equations, eliminate a variable, combine two other equations, eliminate the same variable, and then the new equation 4 and 5, get those together, and then eliminate a new variable, and then you're using substitution from then on out. If you don't like that, then you're going to be using elimination method. And I'm going to write down the equations or the answers that you should be getting. This middle one, notice it's no solution. So how you're going to get no solution when you're using substitution elimination, your variables are going to end up canceling out, and you're going to have two sides that don't equal one another. So maybe like 5 equals 2 or 10 equals negative 7. So then you're going to know it's no solution. If you're using your graphing calculator, you're not going to end up with, on the left-hand side, the ones diagonal. So then that's going to be how you're going to be able to tell that it's a no solution. So always check that left-hand side to make sure it has a solution.